And let's go ahead and draw a couple more polar curves. So we're going to be working out these 5 examples in this video. Feel free to pause it, work it out on your own first, and then you can check with mine. Let's dive into the first one. So for the first one, we're going to be sketching r equals 2. I'm going to just pull it down here. So r equals 2, meaning the radius is 2. So it doesn't matter what theta is, r is always 2. So if you want, you can make a table of values. So pick theta, and then you get your r values. Well, r is always going to be 2. So if you try to draw this, it's at the circle center at 0, 0 of radius 2. So it's going to look like this. So I'm just going to draw the circle first. So that's how r equals 2 looks like. And if you pick theta, for instance, let's say if theta is 0, r is 2. If theta is pi over 2, r is still 2, and so on. So you get the idea. Doesn't matter what theta value you choose, r will always be 2. So r equals to a number will always represent a circle. The next one we're going to draw is this one, r equals to sine theta. So for this one, we are probably not familiar with how the shape would look like. So we're going to come up with table of values and then draw it. So here's our selection for theta. So we'll pick the standard ones, 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we'll have 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So when theta is 0, so we're plugging it in here to figure out the r values. So it will be 2 times sine of 0. So we know sine of 0 is 0. So this would be just 0. And then when theta equals pi over 2, so we're looking at 2 sine of pi over 2. Sine of pi over 2 is 1. So this is 2 times 1. So r is 2. And for pi, so again, we're plugging it back to the original sine of pi. We know that's going to be 0. So this is 2 times 0, which is 0. So this is back to 0. And then you can keep going, but I think we got the picture now. But let's keep going just in case you still want to fill in more points. For 3 pi over 2, sine of 3 pi over 2 is -1. So this is 2 times -1, which would be -2. So this is -2. And sine of 2 pi, we know that's 0. So this would be back to 0. All right, so we got our table of values. Now let's sketch. So here's the Cartesian plane. Here's our x and y. So when theta is 0, we're at 0 right here. And then when theta is pi over 2, so this is 0, this is pi over 2, pi, 3 pi over 2, and 2 pi. So when theta is pi over 2, so when we're reaching at the positive y value, the radius is 2. So we're going to curve it to touch that. And then when the angle is pi, the radius is back to 0. So r is 0. So that's your picture. It's again a circle. So my picture looks a little weird. But this is also a circle of radius 1. So the center is right here. Now, if you keep plotting these points right here, you'll see that you still have the same picture. You're just looping around the same circle. For instance, for 3 pi over 2, so that's right here, where our radius is -2. So instead of being down here, curving it this way, negative radius means you go in the opposite direction. So you're going to loop around here again. And then for 2 pi, we're back to 0. So you're just looping around in that circle. So once we got to 0 to pi, we pretty much have the picture. So this is the picture for if r is equals to 2 sine theta. Another circle, but now the orientation is different from the one we saw previously. Let's go ahead and take a look at the next problem. We're going to graph r equals 3 cosine theta. So for this one, again, we're going to pick the standard values for theta and then plot them. So we'll pick values for theta and we'll have r based on this equation. We'll pick 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So when theta equals, so I'm plugging in right here, when theta is 0, cosine of 0 is 1, so r is 3. When theta is pi over 2, we have 3 times cosine of pi over 2. That's going to be 0. So you'll have 0. And then when theta is pi, you have cosine of pi. So this is 3 times cosine of pi. Cosine of pi is negative 1. So this would be a negative 3. And then for 3 pi over 2, we have cosine of 3 pi over 2. That's going to be 0. So this is going to be back to 0. And then for 2 pi, cosine of 2 pi, that's 1. So 3 times 1, that's going to be 3. All right, so here's our table of value completed. Now let's graph. So here's our Cartesian plane. So this is 0. This is pi over 2, pi, 3 pi over 2, and then 2 pi. So when our theta is 0, we're at 3. Let's suppose this is 3. And then when theta is pi over 2, we're back to 0. So right here. And then when theta is pi, we're negative 3. So instead of going this direction, we're going to go in the opposite direction. So we're going to go this way. So we're back to that. So that's what it means for radius to be negative. You go in the opposite direction. And then when we're going from 3 pi over 2, we're back to 0. So that's right here. And then from 2 pi, we're back to 3. So we're going to loop around right here. So we got our picture. There you go. That's the circle of circle where r is 3 cosine theta. So again, you can see that this equation gives us actually circle of different orientation. So this one is a circle along the x-axis. This one is a circle along the y-axis. And if r is equal to some number a, it's just a circle of that radius. R equals 2 in this case. Now let's take a look at the next one. We're going to be sketching something slightly different. So we are going to sketch this one right here. So for this, we're going to make table of values again. You'll have selection for theta, and then we'll have our r depending on theta. So we'll pick 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we have 1 minus sine of 0. When theta is 0, sine of 0 is 0, so this will just be 1. And then when theta is pi over 2, we will have sine of pi over 2, 1 minus sine of pi over 2. Sine of pi over 2 is 1, so that would be 1 minus 1. That would be 0. And for pi, we are going to get, so sine of pi is 0, so this is 1 minus 0, that's 1. And then for 3 pi over 2, sine of 3 pi over 2, that's going to be negative 1. So this would be 1 minus negative 1, which would be 2. And then for 2 pi, sine of 2 pi, that is going to be 0. So this will just be 1. All right, so I think we have enough points to come up with this sketch. So here's our Cartesian plane. And let's draw them. So here's 0, pi over 2, pi, 3 pi over 2, back to 2 pi. All right, so when theta is 0, our radius is 1. So let's suppose this is 1. And when theta is pi over 2, we're back at 0. So curve it right here. And then for pi, we're at 1. So right here. And then for 3 pi over 2, we're at 2. So let's call this 2. So right here. And then for 2 pi, we're back to 1. There you go. So that's a cardioid. So when you have an equation such as r equals 1 minus sine theta, so when this value and this value, they match. So this is also 1. You can think of it that way. If they match, then they're actually cardioid. heart-looking shape. You can think of it that way. Now, what if they don't match when one of them is greater or less? So that's the next case I'm going to show you. Try to come up with a picture. Again, by making table of values for theta and r. So theta and r. Let's go with the usual ones. 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when theta is 0, so this will be 3 plus 2 cosine of 0. Cosine of 0 is 1. This is 3 plus 2. So that would be 5. And then when theta is pi over 2, we have cosine of pi over 2. That's going to be at 0. So this is 3 plus 0. That would be 3. And then for theta equals pi, so cosine of pi is -1. This is 3 minus 2. That would be 1. And then the next angle we have is 3 pi over 2. So for cosine of 3 pi over 2, that's going to be 0. So this is at 3. And then 2 pi. So we know cosine of 2 pi is 1. So this is going to be 3 plus 2. That's 5. All right. So looks like we have the picture. So here's our XY plane. So let's label them 0, pi over 2, pi, 3 pi over 2, and 2 pi. So for theta equals 0, we're at 5. So let's suppose this is 5. And then for pi over 2, we're at 3. Let's suppose this is 3. So I'm going to curve it to get to that radius. And then for pi, we're at 1. So let's suppose this is 1. So somewhere right here. And then for 3 pi over 2, we're at 3. So suppose that's 3. I'm going to try to draw that again. It looks weird. So this was 1. And then for pi over pi, we have 5. So we're back to 5. All right, so something like this. That's the shape of this. So this is an oval shaped graph. Sometimes it's called a Limacon as well. I have done a different case where these two numbers are different. So such as if this is less than this one, then the shape will be, it'll loop around. So some things like that you'll see in another video. All right, so I hope this helped you understand polar equation a little bit better. See you next time.